let's take a look at our notations for representing isotopes and ions. Recall, isotopes are two atoms that have the same number of protons but different number of neutrons, whereas ions are two atoms that have the same number of protons but a different number of electrons. Isotopes will have different mass but very similar behaviors. Two ions, because electrons are very, very small, will have very, very similar masses but will behave very differently. We like to use two different notations for atomic isotopes. Let's start with the notation up here, which is probably the most common one. Here, X represents your chemical symbol. So for instance, if we were looking at a fluorine isotope, X would be an F there. In the bottom left-hand corner, we have the atomic number, which we represent with the letter Z. But if we recall, the atomic number is just the number of protons, which of course is given on the periodic table. So for fluorine, that would be the number 9. In the top left-hand corner, we have the mass number represented by the letter A. And if we recall, that's just the number of protons plus neutrons. Now the neutrons you cannot get from the periodic table, so this information would have to be provided so that you could figure out the mass number. So let's say, for instance, we are looking at a fluorine isotope with 10 neutrons. That would give him a mass number of 19. 9 protons plus 10 neutrons would give me 19. Now a neutral isotope would just look like this. So it would represent the protons and the mass number, protons plus neutrons. We have the chemical symbol there. And for a neutral element, we know the protons and the electrons should be equal. But sometimes you'll have an atomic symbol or an isotopic notation where you'll have a charge in the upper right-hand corner, where the charge here is given by the protons minus the electrons. So let's say we had a fluorine atom with 10 electrons. The charge in this case would be 9 protons minus 10 electrons would give me a charge of -1. Now, for historical reasons, when we write the charge, we always put the number first and then the sign. And in fact, for a charge of 1, we don't always put the number, but you can. So if you have that charge up there, that tells you that you not only have an isotope, but you also have an ion, has a different number of electrons compared to the neutral element. So all of this information is very nicely contained in these 3 little corners. We have the number of protons, protons plus neutrons, as well as the protons and electrons. So we can figure out protons, neutrons, and electrons from this isotopic symbol. Another shorter notation is this one down here. So in this one, the only extra thing it really puts on here is the mass number. You don't necessarily need the atomic number like we have in the first notation because we can get that information from the periodic table. If we want to represent this same isotope in this other notation, we would still use fluorine. We could still indicate the charge of -1, and then when we do dash, and then the mass number would be 19. So we're leaving off the atomic number, but again, we can get that from the periodic table, so it's not the biggest deal in the world. So these are the 2 types of notations we typically look at. So let's look at a couple examples of how we might be asked to use this notation. So for instance, how many protons, neutrons, and electrons does the arsenic 75 isotope contain? So we know that when we see this notation, this right here is protons plus neutrons, and there's no charge on this guy, so that means for this particular isotope, if there's no charge, my protons and electrons must be equal. So we want to do protons, we want to figure out neutrons, and we want to figure out electrons. Now, protons are easy. We just look at the periodic table. Now, I don't have one here, but you can look at a periodic table, and you can look at the atomic number that's written usually on top of the element, and for arsenic, that is 33. So he must have 33 protons. Now, because it was neutral, we know that protons and electrons were equal for this guy, so he must also have 33 electrons. For the neutrons, we're going to use this piece of information right here. The mass number was 75, and the mass number was protons plus neutrons. So that means the protons, which were 33, plus the neutrons must add up to 75. So we just need to subtract 33 in order to figure out the neutrons. So we learn that this guy has 42 neutrons, 75 minus 33. So we can figure out all three of those from the isotopic notation. We can do it again using the other type of symbol. So here again, this is just a different way of asking the same question. We want protons, neutrons, and electrons, but this time we're using the other notation that we learned about. So this one's a little easier. In the left-hand corner, remember we have protons. In the top left-hand corner, we have protons plus neutrons. And then that charge is given by protons minus electrons. So we just need to keep that in mind for the three corners. So the protons, really easy, is 17. For the neutrons, we know that the protons plus neutrons must add up to 35. So 17 plus however many neutrons we have must add up to 35. Therefore, if we do subtraction, 35 minus 17, that tells me that I have 18 neutrons. Similarly, for the electrons, my protons minus electrons will give me my charge. So here my protons again were 17, and my charge is equal to -1. So there's that negative, that just implies a 1 there. So this time we have to add the 1 to this side. So we do that, we get 18 minus electrons equals 0, and then we isolate the electron. So we figure out my electrons are equal to 18. So just remember, protons minus electrons gives you here charge. Ooh, what did I write there? 18. So for this isotope, we have 17 protons, 17 neutrons, and 18 electrons. Finally, for this last one, it's giving me protons, neutrons, and electrons, and it wants me to fill in the notation right here. The first thing we need to do is figure out the symbol. So we look at the protons. So we look at the element on the periodic table with an atomic number of 26, which is going to be Fe, and that 26 goes in the bottom left-hand corner. To get the top left-hand corner, my mass number, I just need to add up my protons plus my neutrons. So 26 plus 24 gives me 50. So that's what goes right there. And my charge, I just do protons minus electrons. So in this case, 26 minus 24, which is going to be 2. And I want to make sure I note that that's a positive 2. So I put a 2 plus there. So we should be able to go either way, given the symbol, figure out protons, neutrons, electrons, or given those three pieces, figure out how we write the symbol.